Namaskaram students, a very warm welcome to you all to the chemistry session. So I hope each one of you is doing great, and yes, have you revised what we have done so far? In the previous sessions we have covered, yes, we have just started about polymers, started learning about polymers and how they are affecting, how they are relevant in our lives and what all things are formed with which kind of a polymer. So far we have discussed about the classification of the polymers, right, and on the basis of molecular structures, on the basis of molecular forces, on the basis of sources, on the basis of the type of a reaction which is happening in that, and on the basis of the type of structural units which are there, right. So I hope each one of you is clear with the definitions of every entire topic that we have discussed and along with its examples, right. And yes, as I told you, the very important one were the molecular forces. On the basis of molecular forces, we have done two kinds, thermosetting and thermoplastic. These two are very important and many of the questions arise from these topics. Now, in this session, what we are going to start off, yes, we have already started in the previous session, that is the mechanism of the polymerization. I had just told you a little about it, right. So, on the basis of the type of reactions, right, on the basis of type of reactions, what all reactions we have got? So, the reaction that we have got is addition, and yes, we have got is condensation, right. Now, two types of reactions I have got, and yes, I had told you one thing about the addition. Yes, it can also be called, its mechanism can also be called step growth polymerization. It's not like that, right. So, just correct it over here, it's not step growth is for the condensation one, right. And once we are into the mechanism, once we are discussing the mechanism, then you will get to know that why we call it as a step growth, right, and why we call it as a chain growth, right. Step growth and chain growth, you can say reaction or mechanism. Right. Now, we were discussing about the chain growth basically, right. So, I had started with the chain growth. Now, in this chain growth, what first we took? We first took a peroxide, right. It will actually initiate the chain. Now, so the mechanism which is followed over here is free radical, right. You must be knowing that since we are taking up the peroxide, then it is very well understood that peroxide, it gets converted into a radical and then it will initiate the reaction mechanism. So, how does the radical gets generated over here? See, so we already have discussed that, so I am just doing it very quickly. So, that is what benzoyl peroxide, everybody knows that, breaking, right, and a free radical will be generated. And yes, the two molecules of it, and we are not done yet. This is not the initiator basically, but whenever the carbon dioxide is lost from here. So, how does the carbon dioxide is lost? See here carefully, right. As I have discussed this, we have already discussed this, and in fact, you have done this in your 11th standard also, the anti-Markovnikov rule, right. So, that is why I am not explaining each and every step that how the carbon dioxide is released over here. You have to do it on your own, and we get is the phenyl radical, right, the phenyl radical, and this is the phenyl radical which will initiate the first step. What is it? Chain initiation. What is chain initiation? I have to initiate the chain somehow by providing one free radical, by providing one very reactive species into the compound I want to react with, right. And what is the compound that I want to react with? What kind of an addition reaction we are performing here is the formation of polythene, right. And for this polyethene, what do we require? We require is ethene molecule, as simple as that. So, here is the phenyl free radical that was generated along with ethene, right? And I have got n number of molecules of this ethene, right? What will happen? How will it react? So, basically this will be, there will also be a homolytic fission over here, and yes, we get is the free radical. One of them will get attracted towards it and it gets connected. See here, like this. So, it's free radical that we have got over here, another. So, that was the initiation. It has been now initiated, it can go further and further. See, so whenever the chain is going further and further, what do we call that step as? That is known as the chain propagation. Now, I have to propagate it to further steps. So, it is like chain propagation. Now, what is this chain propagation? So, this thing has been initiated. I need another ethene molecule. Let us try to attach another ethene molecule. So, it is C6H5. There will be another free radicals produced and I can link it again. Let us link it again. Right or not? Yes, that is right. And further will be the linkages like this. So, we are not doing this further, it is in fact endless. I need n number of it, right? Because I need to form a polymer basically. So, that is how the chain will propagate, and finally what do we get? This is the repeating unit, right? Right about it? And yes, finally this will be the species which will be generated. Now comes up that how this reaction actually stops. It keeps on propagating and propagating. How will it get stopped? See here, it is the third step basically, it is the chain termination. So, it is the chain termination that we have got. Now, what is that termination? Terminate means stopping in between. How does it stop? It could be a possibility that these kind of two of these species will get connected together and now the stage has been stopped, now the propagation step has been stopped, right? It has been terminated. So, this can be a possibility. One, it is the combination of the two. I have got this species, right? I have got another species just like this. Right? Now, these two get connected, right? And I get my product. So, these two get connected and I get my compound stopped in between. N, CH2, CH2, whole N and C6H5. One of the things. What could be the another possibility? Do you realize anything? So, another possibility is very simple, right? What is it? See here. Okay, I should write it over here only. Yeah. Another possibility could be You see this species? Yes, this is one of the initiators, right? In fact, this is one of the propagators. And yes, this is one species, and another species I have got is a similar kind of a species. It's the N, right? What you can do over here is, you see here this hydrogen basically, if I represent one of this hydrogen like this, right? This hydrogen can give up the electrons here and here, right? A fission will take place, it can give up the electrons, and yes, it will form a double bond over here. One H free radical will be released and gets combined with this molecule, right? Now what do I have? See, right? I've got this thing. Okay, yeah, fine. See here, not this hydrogen will be removed. So this was the structure initially, right? 1, 2, 3, yeah, 1, fine. So this hydrogen will be removed, right? It can give up the electrons, and that is how the double bond will be created. A free radical will be here and a free radical will be generated over here, and they will combine to form a bond, a double bond. Clear? And yes, this hydrogen which is removed, it comes over here. Fine, it's the same thing. So we have got two things over here. Clear? So this thing has also been stopped, this thing has also been stopped. It leads to the chain termination, and that is what the polyethene, that is how the polyethene is formed, right? So this is how the formation of polyethene is done. I hope that is completely clear to you. So that was the entire mechanism. You just have to remember that what are the initiation steps, and specifically this particular step. If you have formed this phenyl free radical somehow, then you will be again, it will be very easy for you to propagate through the entire process very easily. Clear about it? Now that was the chain growth polymerization. I hope it's clear to you. So chain growth polymerization, yes, this specific mechanism is not only applied in the formation of polyethene, but different kind of polymers. Let's discuss that. So I've rubbed this off. So that was chain growth polymerization, and yes, some more addition reactions. What all are those? See, first is, we have discussed about the polyethene. If I try to make it a bit complex, right, HDPE, LDPE. So you must be having an idea about what LDPE is. Yes, what is this? It's low density polyethene, right? It's low density polyethene, that is LDPE. And what about HDPE? It's high density polyethene. So the difference, it lies in the full form itself. It's high density, it's low density, fine. And we have done something related to the type of structures which are present, the type of structures in the polymers, what it is. So basically, what kind of structures have high density and what kind of structures have low density? Now those structures which is having so many links into it, right? See here, if there are branches present in between the two chains of the polymers, then it will be low density, it will be having less strength because here the packing is improper, irregular. Whereas if I talk about high density, so basically these chains are stacked onto one another and that too in a proper fashion, leading to the formation of high density, high tensile strength, durability and high melting point. So that is what the difference between the two is first of all. So this is branched, this is linear, right, and this is having low density. They have already mentioned into the full form itself, right, and what else, this is transparent, this is translucent. Fine. So that is some of the differences between the two, and yes, it's used to make thin films. It's used to make thin films, plastic films I'm talking about, films, plastic bags, right, etc. And in fact those squeezy bottles that we have, right, so squeezy bottles, now in this, since it's high density, we can use it for what, for the formation of buckets, right, so plastic buckets. We have got chairs, tables, etc., right, so many kinds of uses, and it's just a plastic basically. So we have done about the polyethylene, right, so that was the very basic polymerization that we have done. But what if I need to convert that simple polyethylene into LDPE or HDPE, right, low density polyethylene or high density? Let's talk about that. So it has got specific reactions. So basically the general mechanism will remain the same. What it is? It's the free radical mechanism. We have just discussed is the chain growth, and these are basically the examples for the chain growth. Let me just write. Followed only by the free radical mechanism. Clear? Now, if I talk about, okay, in the terms of chain growth only, first the formation of LDPE. So what happens is, see, so as I told you, there will be a little branches over here which will be present inside. How the branches are made? Let's see here. So there is an ethene molecule, remember, and yes, this ethene molecule will be connecting with, since there is the free radical mechanism going on, so it will be connected somehow with this, right? It's like this. Right. Fine. It will be connected somehow like this, and yes, there is a possibility that there will be a chain, a longer chain also, right? There will be a very long chain, in fact, of n number of atoms also. Let's say C6H5 over here and a free radical here this time. Now what happens is, instead of this free radical, or what happens, if I can have another ethene molecule over here, another free radical generated, or this could be the one possibility. If I talk about another kind of possibility, see here. Now, what can happen is, one free radical can be generated from there also, or if I see here, yeah, just to make sure, and this was the free radical that we had, fine. Fine. So a double bond will be generated here, a H free radical will be over here. So over here another free radical will be generated and it will form a double bond here, and hydrogen free radical will come off, right. This could be a possibility. So, several possibilities we have discussed in the chain initiation, propagation and termination. Fine. Now comes up how the branch will be formed, right? How branch is formed. So, we have got several possibilities over here. One of the possibilities can be yeah, okay, let's just let it remain as it is. If I just disturb this hydrogen here somehow, it should not be 2 but only 1, right? Let's just disturb this a little bit. Fine, what do I have? C6H5, CH2, oh wait, CH2, CH free radical coming over here now, CH2 free radical. Fine. Now there is a possibility that this ethene molecule which I have just drawn, there is a possibility that this ethene molecule which I have drawn can come and fix over here, right? This free radical, like this. Are you able to get me? See here how the attachment will be done. Can you see? Now there is a branch which has been generated within the molecule. Not in fact just the straight chain, but there is a possibility that a hydrogen from somewhere in the middle can come up and it will go off in the form of a free radical, generating a free radical over there in somewhere in the middle, and yes, thereby generating a branch. So that is how the branches have been generated, and that's why due to these branches there will be a very irregular packing, and thereby it's low density polyethene that is formed. Clear about the fact? I hope that is completely clear to you that how the branches have been made over here. Fine. Now, what is the possible process happening? So it's, wait, yeah. So the possible process which can happen is CH2, right, and N times we have taken up. Now the conditions, these are very important. The conditions are 350 to 370 kelvins, 1000 to 2000. For such a branched chain formation, we need is very vigorous conditions, very harsh conditions over here. So it's 350 to 370 Kelvin, so much of temperature, along with so much of atmospheric pressure, 1000 to 2000, right? And yes, we get is LDPE. Clear? And we have just discussed that what all are the things included, what all are the facts about LDPE. Fine. Now comes up the reaction for HDPE. It's simple, it's similar. So it will be a proper packing, so thereby it's a straight long chain. Similar concept, similar mechanism, free radical mechanism only, and using the peroxide only. So it's this only, and now the conditions will be. So the condition is basically 333 Kelvin. Now pay attention. 6 to 7 atmospheric pressure, and yes, a very special catalyst over here used is triethyl aluminium CH2, triethyl aluminium plus titanium chloride TiCl4, and we get the required polymer, that is HDPE. Now what is the name for this catalyst over here? It's a very special catalyst known as Ziegler-Natta catalyst. Ziegler-Natta catalyst. Clear? So these were two reactions, and in fact whenever you are writing down, whenever the question comes up that you have to form the polythene, right? So most of the cases you need to write this particular reaction along with the catalyst, along with each and every condition, right? And in fact whenever they ask for the LDPE also, again you need to write down the conditions that will actually will eliminate all the risk of losing any marks in the exam. Clear? So that was some of the addition reactions that we have just discussed. In the next session, yes, I will be taking up some more examples along with the remaining mechanism of that of the condensation, right? We are not done yet with the mechanism part. We still have one mechanism left, right? And that is what we are going to discuss in the next session. Have a very good day.